Hello students, for the recommendation of the students, there are certain topics we have to cover in this lecture. So the first topic is Euler's phi function. So in the Euler's phi function, the function finds that the number of integers that are both smaller than n and co-prime to n means are relatively prime to a number n. Relatively prime means if we find out the GCD between a number n as well as that integer, then the answer should be 1. So that is the Euler phi function. This Euler phi function will be denoted by phi, and this is the value of an integer, that is n, and this is a. So this is the number of integers that are both smaller than this value and which are relatively prime to this value. So Euler's phi function have four equations. The first one is Euler function of 1 equal to 0, means we have to find those integers which are less than the value of 1 and the GCD of that integer and 1 should be equal to 1. Now the second one is GCD of phi and p, where p is the prime number. It is a prime number. So in the case of prime number p, all the values from 1 to p minus 1 will be the set of integers, because these values are co-prime with the value of p. And the third one is Euler function phi m cross n, where m and n is not necessary to be a prime number. The multiplication of two integers is not necessarily a prime number. So if the integers inside the function, that is m cross n, then it should be phi of m into phi of n. You have to solve it by using phi of m and into phi of n. And the last one, fourth one, is related to the power of a prime number. We have a prime number and it contains some power. So in this case, I have break this equation in the way p to the power a and p to the power e minus 1. So the first one is phi of 1 equal to 0. The second one is phi of p, where p is a prime number, equal to p minus 1. So when we are talking about the prime number theory, so all the integers from 1 to p minus 1 should be relatively prime to p. And the third one is the phi of m cross n. This is the factorization time of problem, where two prime numbers are combined in the multiplication form. Then we have to break out in the form of phi of m into phi of n. And the last one, we have to try out for the powers of prime number, that is phi of p to the power e, where e is the power. So we have to break out like p to the power e minus p to the power e minus 1. So in this next section, I will clear some of the questions. Like the first question is, we have to solve out phi of 13. So now we can see that 13 is the prime number. So the formula phi of p equal to p minus 1 we have to use, where this value is p. So what should be the answer? P minus 1 means 13 minus 1 equal to 12. 12 is the answer. Very simple questions. Then question number 2 is phi of 10. So now 10 is not the prime number, so we have to do the factors of this. In the factors, what is the factors of 10? That is 5 into 2. So by using the third formula, that is third formula, that is phi of m into n equal to phi of m into phi of n. So in this case, it will be treated as phi of phi into phi of 2. Now what will be the answer? That is 4 into 1, and 4 is the answer. The another question is phi of 240. So it is not the prime number 240, then we have to find out the factors. So what is the factor? The factor is 2 to the power 4, 3 to the power 1 and 5 to the power 1. So again it follows the third equation. What is the third equation? The third equation is phi of p to the power e, where p is the prime number and e is the power. 2 is the prime number and this 4 is the power. 3 is the prime number and 1 is the power. 5 is the prime number and 1 is the power. So what is the breakout? P to the power e minus p to the power e minus 1. So in this case it will be treated as 2 to the power 4, 2 to the power 3 into 3 to the power 1 minus 3 to the power 0 into 5 to the power 1 minus 5 to the power 0. So after solving out, the answer should be 64. Now there are some applications of this Euler's Phi function, that is for the set of residuals. If you are talking about the set of residuals, that is Z14 into this is the multiplication inverses. This set contains the multiplicative inverses and it is a set of residuals which contains the multiplicative inverses. Here the star indicates a multiplicative inverse, and how many number of elements in this set of residuals? The number of elements should be 0 to 14 minus 1, like 13. So the question is how many number of elements in the multiplicative set or residual. Simple, you have to find out the value of in, where n value is 14. So n value is 14, find out the value of 514. So this is not the prime number, then we have to do the factorization. So 7 into 2 is the factor. Now the third equation, that is 7 into 5 of 2, both are the prime numbers. So second formula will be applied, that is phi of p equal to p minus 1. So it will be 6 and it will be 1. The answer is 6. So the question is how many elements in the set of residuals which contain the multiplicative inverse. So the answer is there are 6 elements in the set of residuals Z14 star. Now the another topic is called Fermat's little theorem. So Fermat's little theorem is not clear a lot of students, so they recommended me to make a video over this topic. So again I am teaching you the Fermat little theorem. So it is not the Fermat, that is Fermat's little theorem. So Fermat little theorem says if p is a prime number, p is your prime number, and a is an integer. P is a prime number and a is integer. In this case, a to the power p means integer to the power prime number, a to the power p minus a. This equation will give you an integer a to the power p minus a. This equation will give you an integer that should be multiple of a prime number. Don't worry, I will give you one example. Please don't confuse, just concentrate on my sentence. That is, if p is a prime number and a is an integer, then the equation, that is a to the power p minus a, will give you an integer that should be the multiple of a given prime number. The example is, suppose I am taking a value is 2 and p value is 7. Okay, so what will be the value of this equation? A to the power p means 2 to the power 7 minus 2. The answer is 128 minus 2 means 126. And what is the factor of 126? The factor of 126 is 7 into 18. Okay, now you can see this 7 is again the value of p. So that's why the sentence tells you that a to the power p minus a gives you an integer that is 126, that should be the multiple of a prime number. So it should be the multiple of a prime number, that is, if you are multiplied 18 into this prime number, you will get a to the power p minus a. So Fermat-Little's theorem will give you this concept. So according to this concept, why it's not adding page? So according to this concept, there are two equations. Like we can say a to the power p minus a integer should be multiple of p, then after taking the modulus operation of this integer, the value should be 0. If a to the power p minus a integer, a to the power p minus a gives you an integer which is a multiple of p, means it is divided by p. If it is divided by p, then you will got the answer 0 after performing the modulus operation. So a to the power p equal to a mod p. You can write this equation like this way, and this is the Fermat's little theorem first equation. Okay, that is the first equation. Now the second thing, divide both side by a. So a to the power p divided by a and 1 mod p. This equation can be transformed as a to the power p minus 1 congruence property 1 mod p. What is the congruence property? I told you 1000 times in the class that the congruence property is whenever I performed an operation on the left hand side, that operation should be equally applicable on the right hand side equation. That is called the congruence property. So there is a mod p operation at the right hand side, then the equivalent mod p operation have to be applied at the left hand side. So this is the second equation. So Fermat's little theorem provides you two equations. The first one is a to the power p congruence property a mod p, and the second one is a to the power p minus 1 congruence property 1 mod p. So application of the Fermat's theorem is used to solve some typical equations. Like the question is, you have to solve 6 to the power 10 mod 11. So here 6 is the value of a, 11 is your p. What is p minus 1? P minus 1 equal to 11 minus 1 equal to 10. What is the Fermat's little theorem? A to the power p minus 1 mod p equal to 1. That is the Fermat's little theorem. So this equation is satisfied over there. So the answer is 1. Now the question second. The question says 3 to the power 12 mod 11. So in this case 3 is your a, 11 is your p, and what is 12? What is the p minus 1 value? P minus 1 is 10, but here there is 12. So break out this equation simply. So 3 to the power 2 and 3 to the power 10 mod 11. This term will automatically will be 1, and again there is a mod 11. So what will be the last answer? That is 9 mod 11, and the answer is 9. So what about the multiplicative inverse by using the Fermat's little theorem? Multiplicative inverse. So for a to the power p minus 1 equal to 1 mod p. Just multiply a inverse into the both side. So after multiplication it will be converted as a to the power p minus 2, and it will be converted as a inverse mod p. Now you can say a inverse mod p will be equal to congruence to the congruence property a to the power p minus 2 mod p. So this is the formula in order to find out the multiplicative inverse. Just listen, don't worry about the example. I will solve the example for you. Now the next topic is Euler's theorem. The previous one was Euler's totient function, Euler's phi function. Now the Euler's theorem. So Euler's theorem is derived from Euler's phi function. ठीक है, by applying the some Fermat's little theorem concept over there. So what was the Euler's first theorem? Sorry, Fermat's little theorem. Fermat's little theorem, the first one is a to the power p minus 1 congruence property 1 mod p. Now you can see there, according to the Fermat's little theorem, phi of p equal to p minus 1. Now substitute this p minus 1 by phi p here. So a to the power phi p congruence property 1 mod p. Now this is the Euler's first theorem. Simple. Just apply the Fermat's little theorem concept over there. Then what is the second? The second one is a to the power p equal to a mod p. And it is simply written as a to the power k into phi p plus 1 should be congruent to 1 mod p. Sorry, a mod p. So what are the examples? The first example is 6 to the power 24 mod 35. So first you have to calculate the value of phi p. This is the value of p, this is the value of e. So what is the value of phi p? Value of phi p is value of phi 35. It is not the prime numbers, and then you have to do the factorization process like 7 into 5. So 7 is the prime number and 5 is the prime number. What should be the answer? 5 of 7 into 5 of 5. So in this case, this will be 6 and this will be 4, and the answer is 24. Now you can see phi of p, that is 24, is exactly the same as this value. Means it is in the form of phi of p mod p, and the value of this equation is 1. So directly the answer is 1, because this equation satisfies this equation. Now the question, 20 to the power 62 mod 77. So again you have to calculate the value of phi 77. It is not the prime number, then you have to do the factorization. So 11 into 7, then phi of 11 into phi of 7 by applying the third property. This is the prime number, this is the prime number, then the value of 10 by applying the second property. The value is 60. Now the phi of p is 60 and here is 62. So we have to break out this equation. So in order to break out, we have to do 20 to the power 60 and mod 77 and mod 77. So in this case, this whole term will be equal to 1. Okay, like a to the power phi n and mod p. So by using this equation, this will be equal to 1. So what will be the second? That is 400 mod 77. After solving, the answer is 15. Then what about the multiplicative inverses? For the multiplicative inverse of the Euler's theorem, just follow A inverse mod n congruent property a to the power phi n minus 1 mod n. Just apply the, in this part, multiply by A inverse both of sides, and you will find out the multiplicative inverse by using the Euler's theorem. So the multiplicative inverse, in order to find out the multiplicative inverse, there are two ways. The first one is by using in order to find out the GCD, and the second one is modular exponential. So what is the modular exponential? So the modular exponential will solve the exponential type of problem by taking the powers of a particular integer, the decimal value. It will convert it into the binary value. What is the binary value of 11? 1011. And according to this binary value, it will calculate the multiplicative inverse of a particular number. So in a very short way, I will tell you what is the procedure behind this in a very short way. The first one is, in order to solve this type of equation, you have to fix some things. Like, I will solve this equation, the multiplicative inverse of A inverse 77, by using the modular exponential algorithm. So in order to solve out this type of equation, this is the value of B, this is the value of M. Now apply the Euler's phi function here. Okay. In the Euler's phi function, you have to first calculate the value of 577. The value of 577 is 11 into 7 means 60. Right. So what is the equation? A inverse mod P equal to A to the power phi n minus 1 mod 77. That was the equation. This one. So same equation I have applied over there. So it can be write as A to the power phi n. What is the value of phi n? That is 60 minus 1 and mod 77. What is the value of A? Sorry, it is the value of A now. So in this equation, your A equal to B. So 8, 60 minus 1 and mod 77. So what will be my equation? The final equation is A to the power 59 mod 77. Now the value of B is 8, the value of M is 77, and the value of A is 59. First, consider A and convert it into binary. So I am solving this equation, that is exponential type of problem, by using the modular exponential. So first you have to consider the power, that is 59, put it into the A and convert it into the binary form. The second one is check the value of A is 0 or 1. If the value of A is 0, then you have to fix a constant. The first thing, you have to fix a constant x equal to 1, and the second one is the power. You need two integers. The first one is x equal to 1 and the second one is the power. So what is the power here? The power is A mod 77, means B mod M. So the answer is 8. So now come to the second point. Check A equal to 0 or 1. If A equal to 0, then no updation on x, else x value will be updated by x equal to x into power and mod M. And the third one is, you have to calculate the value of power. The power is power square and mod M. You have to follow only these three steps. The first one is, just identify the value of B, A and M. Then put the integer x equal to 1 and power equal to B mod M. The answer is 8. Now the follow 3 steps. The first one is consider a and convert it into the binary form, means we have to convert the 59 into the binary form. Second, we have to check the value of a is 0 or 1. If value of a is 0, then there is no updation on x will be satisfied as x will be considered the previous value. And the another one is a equal to 1. If a equal to 1, then you have to calculate the new value of x by using the following equation, that is x equal to x into power mod m. And the third one is you have to calculate the power at the last, that is power equal to power square mod m. So after following these 3 steps, you have to you will successfully get it the value of modular exponential type of problems. So my equation is a to the power 59 mod 77, x equal to 1, power equal to b mod m. This is your b, this is your a, and this is your m. So b mod m is 8 mod 77 is 8. Now the value of a is 5910. The first step was converted into the binary. What is the binary value of 59? That is 111011. This is the binary form. Now give the numbering 0 1 2 3 4 5. Now these are the iterations, mean I have to follow my algorithm. I have to iterate my algorithm from 0 to 5 times. So start the iteration number 0. So at the iteration number 0, what is the value of a0? a0 this value is 1 here, this value, so this value is 1 here. Now just follow the previous step. What was that? If the value of a equal to 0, then there is a no updation of x. If a equal to 1, then there should be an updation of x by using this equation, that is x equal to x into power mod m. So x equal to, what is the previous value of x? 1. x equal to, मैं formula लिख देती हूँ, that is x equal to x into power mod m. So previous value of x equal to 1, the power is 8 and mod m. What is the value of m? That is 77. So the answer is 8. Now the third step, that is power. So power is power square mod m. What is the previous value of power? That is 8. 8 square mod 77. The value is 64. Now my first iteration is complete. My second iteration, that is I equal to 1. So I equal to 1, what is the value of a1 here? a1 value is 1. a1 equal to 1 means I have to update the values of x. What is the value of x? X into power mod m. What is the previous value of x? 8. What is the power value? 64. Then mod 77. Now after the multiplication and performing the modulo, the answer is 50. Now power. So power is power square mod m. What is the previous value of power? 64 mod 77. Now the answer is 15. You have to solve with this equation, that is 64 square mod 77, by using your calci. There is no specific procedure over this. So I equal to 2. So in this I equal to 2, what is the value of a2? That is 0 here. So I equal to 2. Sorry. A of 2 is 0. X equal to, what will be the value of x? The value of x will be the previous value of x equal to 50. Now according to my term, my a equal to 0 means there is no updation on x. So x will be as it is, remaining same the previous value, but I have to calculate the power. So power equal to power square mod 77. What is the power square? That is 15 square mod 77 and it is 71. Now I equal to 3. For I equal to 3, what is the a3 value? The a3 value is 1, means we have to update the value of x. The value of x will be previous value of x and the power value and mod 77. After multiplication and followed by the modulo operation, the answer is 8. And what should be the power value? The power value is previous power value square and mod 77. So after solving,